Hello, my name is Mr. Asprey and this is MadAsMaths Paper C MP2. If you find this useful, please do like the video, please do subscribe to my channel and share with your friends. Let's do it. Here we go. Question number 1. Expand this series. So we're going to use the binomial formula and we need the number next to the x to be 1. So I'm going to take out a root 225. So that gives me 1 plus 15 over 225x. This is f of x. So this is the same as 15 because that's the square root of 25. Open brackets, 1 plus, and 15 over 225 is 1 over 15. X to the power of a half because it's the square root. Okay, so this gives me, when I use my formula, we have 1 plus nx, which is 1/2 times by 1 over 15x, plus n, which is a half, times by n minus 1, all over 2 factorial times by x to the power 2. And that's as far as we need to go, because it asks only up to the second, so the x squared term. Okay, now we need to just expand this. So I'll start by expanding without the 15. So we get 1, and that's going to be plus 1 over 30x. And this one I'll need to do on my calculator. So I will do 0.5 times minus 0.5 over 2 factorial, which is 2, times by 1 over 15 all squared. And we get minus, so that should be a minus, 1 over 1800 x squared. Okay, now let's multiply through by 15. So that gives me 15 plus, that will be a half x, and this will be minus 1 over 120 x squared. Perfect. Okay, part B asks me to sub in x equals 1 into the expansion. Okay, well, when I sub x equals 1 into this, I will get the square root of 224. So if we let x equal 1, then we're going to get the square root of 240. And we sub it into my expansion as well. So I'm going to get 15 plus a half times 1 is a half, and then minus 1 over 120 times 1 squared is just minus 1 over 120. And I get this. So that's equal to, or approximately equal to, I should say, 1859 over 120. Okay, so 240 divided by 15 is 16. So I can write this as root 16 times root 15. Which is the same as 4 root 15. So therefore root 15 divided by 4 is the same as multiplying the denominator by 4, which gives me 480 as required. Question number 2, and we have a geometric progression are given in sequential order as such. Show that one possible value of p is a quarter and find the other. So if they are in geometric progression, that means that we multiply by some constant ratio from one to the other. So we can write that 1/2 divided by 1 minus 5p is equal to r. And we can also write that 4p minus 2 divided by 1/2 is also equal to r. Okay, so we can equate these. If they're both equal to r, they must both be equal to one another. So we write this. And then we cross multiply. So we get 1/4 is equal to 4p minus 2, 1 minus 5p. Okay, great. So let's try and solve that. I'll expand the brackets first. And that will give me 4p minus 20p squared minus 2 plus 10p. I will then moving over to the left hand side to get 20p squared. That's 14p, so minus 14p when I move it over. And add the 2 on is going to give me plus 9 over 4 equals 0. Right, I'm then going to solve that quadratic on my calculator. So it is 20 minus 14 and 9 over 4. We get 9 over 20 and we get 1/4. Perfect. So x equals 9 over 20, x equals 1/4. Question number 3, we've got the curve intersects the straight line at the point P whose x coordinate is alpha. Show that alpha is between 0 and 1. Okay, so where they intersect is the solution to the simultaneous equation. So that will be 2x is equal to 3 minus, 2 to the x is equal to 3 minus 2x. I can bring it all over to one side, like such, and then I can substitute into this function x equals 1 and x equals 0. And what I'm looking for is a change of sign, because if there's a change of sign between 1 and 0, then it means the curve must cross through the x-axis, and therefore there must be a root to this equation, which means there's a solution to this equation, which means there is an intersection point. Okay, so when x equals 1, we get 2 plus 2 minus 3, which is equal to 1. And when x is 0, we just get minus 3. Okay, so we can say that as the function is continuous and there is a change of sign on the interval between 0 and 1, we must have at least one root. Great. Okay, that's proved. And now we're going on to part B, where we are using the Newton-Raphson method. So the Newton-Raphson method is that xn plus 1 is equal to xn minus subbing the x value into the function and then subbing the x value into the derivative. And the function that we're going to use, of course, is this this light blue one up here, and that is 2x plus 2 to the x plus 2x minus 3. So the derivative of that, which we're going to need, is 2x ln 2 plus 2. Okay, so I'll need to sub in 0.5. So I get 0.5 minus, and then 0.5 goes in here, plus 2 lots of 0.5 minus 3 over the derivative, so it'll be 2 to the 0.5 ln of 2 plus 2. And the question asks us to find the value of alpha to 3 significant 3 decimal places. So we're going to get our calculator and we're going to type 0.5 equals, and then we're going to set up our Newton-Raphson equation using the answer button. So the first x is, we use answer, and then we do minus, and then we do a fraction, and we do 2 to the power of the answer, and then we do plus 2 times the answer, and then minus 3, and then we go underneath and we do 2 to the power of the answer, and then we do ln of 2, and then we do plus 2. We press equals, and that gives us our first value, and then we press equals again, we get our second value, and we press equals again, and you can see now after I continue to press equals, it's fixed on that, so we've converged to the root. So alpha to 3 significant figures is equal to 0.692. Perfect. Question 4, we've got a triangle and we've got a sector as well, and it says that it shows the circular arc OAB of radius 12 subtending an angle of 3 pi over 10 radians. It says find to 3 significant figures the length of arc AB. Okay, so the length of arc AB, the arc length is equal to r theta, which in this case is equal to 12 multiplied by 3 pi over 10. So that's the same as 36 pi over 10, which is 18 pi over 5. And they want that to 3 significant figures, so I'm going to have to use my calculator there. I'll do 18 over 5 multiplied by pi. And I get 11.3. Okay, great. Next, the area of the sector. Well, we know the area of the sector formula is equal to a half r squared theta. So this will be a half times by 12 squared times by 3 pi over 10. And I'll just put that straight in my calculator. So that's 0.5 times 12 squared times 3 pi over 10. And to 3 significant figures, that is 67.9. Great. Of course, this is centimeters and this is centimeters squared. Okay. And now we have the point C lies on OB such that OC is equal to OA. You can see that drawn out there. Determine to 3 significant figures the perimeter and area of R. Which is this the area here? Okay. So we can find some of the missing sides. So because these two are equal sides, then we know this angle up here is also 3 pi over 10, which means that we can work out the missing angle down there at C by doing inside a triangle there is 180 degrees, so that's pi radians. So we could do pi minus 3 pi over 10 plus 3 pi over 10 is 6 pi over 10. So of course that will leave us with 4 pi over 10, or 2/5 pi. Okay, so that's that angle there. And now what I can do is I can use the sine rule to work out, let's say, well, this side here, this purple side, AC. So I can say that, I might do it up here, I can say that AC over sine of this angle of the angle opposite it, which is this one over here, 3 pi over 10, is equal to 12 over sine of 2 pi over 5. Okay, great. So I can rearrange to get AC. I'll do that on my calculator. I'll do the 12 over, I just need to make sure my calculator is in radian mode, sine of 2 pi over 5 and then I'm going to multiply that by the denominator of the left side, which is sine of 3 pi over 10. Okay, great, so I get 10.2. So that's that at the side there is 10.2. So with that I can work out the perimeter. So the perimeter P is equal to that 10.2 side plus this arc length, which we've already worked out, was 11.3. And this little bit here is the radius of the sector minus the 10.2. So this is equal to 12 minus 10.2. So adding those up, we're going to get 23.3 centimetres for the perimeter. Okay, and we're also asked to work out the area. And the area will equal the area of the sector, which again we've already worked out. The area of that sector was 67.9 minus the area of the triangle, which is unshaded. And the area of the triangle is a half. Two sides which are adjacent and the angle in between will be what we're going to use. So it will be times 10.2 times 10.2 times by sine of the angle which is between the two sides, which is 2 pi over 5. Okay, so it is 67.9 minus a half multiplied by 10.2 times 10.2 times sine of 2 pi over 5, and we get 18.4 centimetres squared. Great. Use proof by contradiction to show that if x, then the modulus of x plus 1 over x is greater than 2 or greater than equal to 2. Okay, so what we're going to do is we're going to assume, I suspect that's meant to say x is in the reals. It doesn't really make sense otherwise. Use the method to show that if x is a real number, then assume x is a real number and the modulus of x plus 1 over x is less than 2. So that's the opposite. Okay, so straight off the bat, what I'm going to do is I'm going to square both sides, because that will just take care of that modulus, and I will know that will be less than 4. Because whether or not this is negative or positive, if I square it, it's not going to matter. So that is good. When I square this out, I get x squared plus 1 plus another 1 plus 1 over x squared is less than 4. So this gives me x squared plus 2 plus 1 over x squared is less than 4, which gives me x squared minus 2 plus 1 over x squared is less than 0. And this can be refactorized. So just in the same way that this here, when it expanded, we got this. Well, if I just change the sign to a minus, then it's going to give me this. So I could write that x minus 1 over x all squared is less than 0 now. And this is a contradiction. Because a square can't be less than 0. And then you can write therefore for all x in the reals the modulus of x plus 1 over x is greater than or equal to 2. Okay, we've got vectors question next, and we've got variable points a and b, and we need to show that the modulus of a to b is equal to this square root. So if I want to work out a to b, then I will do OB minus OA, and this will give me T41 minus 2t, t and 2, and this will give me minus t, it will give me 4 minus t, and it will give me minus 1. Okay, so the modulus of that, the modulus of AB is equal to the square root of the component squared. So this one here is going to be minus t all squared plus 4 minus t all squared plus minus 1 all squared. Okay, let's expand this out. We get t squared, we're going to get a 16 minus a 40, and a minus another 40 is minus 8t. We're going to get a plus a t squared, and we're going to get a plus 1. Let us simplify this to get 2t squared minus 8t plus 17, and that is as required. Beautiful. Hence find the shortest distance between A and B as t varies. Okay, so we want to minimise this, don't we? So we want to minimise this. So what we'll do is we will complete the square. So I'll take the 2 out, and I will write t squared minus 4t plus 17. I will then make that t minus 2 all squared minus 2 squared, which is 4 plus 17. And then multiplying out, I get 2 lots of t minus 2 squared minus 8 plus 17, which is 2t minus 2, and that is plus 9. Okay, so the smallest possible value that we can get is 9. And that happens when t is equal to 2. We have our modulus of AB equal to the square root of 9, which is equal to 3. So that is the minimum distance. Okay, we've got two parametric equations, and it says show clearly that dy by dx is equal to 2t minus t squared. So we are going to have to differentiate each of these, and I will start by differentiating the y first. So dy by dt, I'm going to have to use the quotient rule here. So I'll set it up with obviously u being the top and v being the bottom, and we start by saying v multiplied by du, which is the top, differentiated, minus u, which is just the top, multiplied by dv, which is the bottom differentiated, which is just 1, so I won't need to multiply it through there. And that's all over v squared, which is the bottom squared. Okay, this can simplify. So multiplying out the brackets on the top, I'm going to get 2t squared, I'm going to get a minus 2t and minus another 2t, so that's minus 4t. And I'm also going to get a plus 2, and then I'm going to take away a t squared, take away a minus t, 2t, sorry, which is plus 2t, and take away a 2 like that. Again, that's all over t minus 1 squared. So this is going to simplify to t squared minus 2t, that's it, all over t minus 1 squared. Okay, great. Now what I'm going to do is differentiate the x. Okay, so quotient all again. This time we start again with v, so t minus 1 multiplied by du, which is just free, and then I need to take away u, which is 3t minus 2, multiplied by dv, which is just 1, and that's all over v squared. Okay, so multiplying out the top, I'm going to get 3t. I'm also going to get minus 3t, and I'm going to get a minus 3, and I'm going to get a minus 2, which is a plus 2. So minus 3 plus 2 is minus 1, so I'm just going to get minus 1 over t minus 1 all squared. Okay, great. And now I can do dy by dx, and that is dy by dt over dx by dt. So that will be t squared minus 2t over t minus 1 all squared, all over minus 1 over t minus 1 all squared. So these can cancel, because both the top and the bottom have a factor of 1 over t minus 1 all squared. And if I'm dividing through by minus 1, I'm just going to be flipping around the coefficients here. So that will be 2t minus t squared. Okay, brilliant. Okay, next question. The point P, which is 1 minus 5 over 2, lies on C. Show that the equation of the tangent to C at the point P is given as that. Okay, so the equation of the tangent, you're going to have to sub in the x-coordinate, or at least we're going to have to find what the t value is. Yes, let's do that. So I want to investigate when x is equal to 1. So I'm going to take this x-coordinate here, and I'm going to set it equal to 1. So I'm going to get 1 is equal to 3t minus 2 over t minus 1, which gives me that t minus 1 is equal to 3t minus 2. So I'm going to get 1 is equal to 2t, so I'm going to get t is equal to 1/2. Okay, great. If t is equal to 1/2, then I can sub that into my gradient function to get the gradient, and then I know 2 points, so I can work out the equation of a line. Okay, so into the gradient function goes t equal 1/2, and that's going to give me 2 times 1/2 is 1, and 1/2 squared is 1/4, so that is 3/4. Okay, now we need to do equation of a straight line. So y minus y1, which is minus 5 over 2, so 2 minuses make a plus, 5 over 2, is equal to the gradient function, the gradient at the point, which we worked out was 3/4, and then x minus the x-coordinate, which we knew was 1. Okay, multiply everything through by 4. This is going to give me 10. And then I can multiply this bracket out by 3, which gives me 3x minus 3. And then how do they want it? All on one side. So I get 4y minus 3x plus 13 equals 0. Whoops, just spotted that they want it all on the other side. So 0 is equal to 3x minus 4y minus 13 is how they asked for it. Same difference. Okay, question 8. It says calculate the following missing values of the table. It's a bit cheeky, this, because it doesn't necessarily explain that they have to be. Well, it is for the trapezium rule, so we can look ahead and say it's for the trapezium rule. So I can rewrite this as or ln 8 is equal to ln of 2 to the power of 3, which is equal to 3 ln 2. So if I write that as 3 ln 2, then if this is 1 ln 2 here, then halfway between them would be 2 ln 2. So this would be 1.5 ln 2, and this would be 2.5 ln 2. Okay, so we just need to put these into our calculator now. Yeah, this is not going to be particularly fun. So we'll do E to the power of 2 times 1.5 ln 2 is 3 ln 2. And that's all over E to the 1.5 ln 2 and then plus 1. Okay, so we get 2.0896. Okay, then we go back, change that to a 2, change that to a 4, this is riveting stuff, 3.2, and then we'll change that. I mean, how exciting is this? This is putting Mr. Beast to shame. 4.807. Okay, and now we are asked to use the Trapezium rule to find an estimate for this. Okay, so again, just calculator work here. The Trapezium rule is that you need to take the gap between them, which in this case is 0.5 ln 2, and you will need to halve that, and then you will need to multiply it by the first term plus the final term plus 2 times by the middle terms added together. And you get an answer of 4.962. Brilliant. Okay, use the substitution. This is a bit more exciting. U is equal to e to the x plus 1 to find an exact simplified value for it. Okie dokie. So with any substitution, the first thing I'll do is differentiate. So du by dx is equal to just e to the x. And then I will write that as du by dx is equal to, well, I know that e to the x is equal to u minus 1. So that's equal to u minus 1. And then rearranging that gives me du over u minus 1 is equal to dx. So great, I've got dx on its own. And I've also, the denominator is all good, but the numerator needs a bit of work. So what I'll do is I'll take this and I will square it, which gives me e to the x squared is equal to u minus 1 squared, and of course e to the x squared is e to the 2x. So I've got that sorted out, and then also I need to sort out my limits. So I'll have x values and I'll have u values. So my x values are ln 8 and ln 2, and when I sub them up into here, I get e to the ln 8, which is just 8, plus 1 is 9. And then I'll get e to the ln 2, which is just 2, plus 1 is 3. Okay, so I think I'm good to go. So I will write that the integral is equal to the integral between 9 and 3 of u minus 1 all squared all over, this yellow bit here is just u, and then dx is du over u minus 1. Okay, great. I can cancel off a u minus 1, like so. So this becomes the integral between 9 and 3 of u minus 1 over u du. And with this I will split it up, and it will become u over u minus 1 over u. So that's the same as 1 minus 1 over u. And then integrating will give me u, and that will be minus ln u between 9 and 3. And then subbing in, I'm going to get 9 minus ln 9 minus 3 minus ln 3. 9 minus 3 is 6. And I'm going to have a minus ln 9. And I'm going to have a positive ln 3. So that is the same as ln of 3 over 9. And I think that's good. 6 plus ln of 1/3. And I guess if you wanted to get fancy with it, you could write that as 6 minus ln 3. Probably the best way. I think that's good. The shape of a weather balloon remains spherical at all times. It's filled with a special type of gas and is floating at a very high altitude. The rate at which the volume of the balloon is decreasing is directly proportional to the square of the surface area of the balloon at that instant. Let x be the radius of the balloon, t hours since r is equal to 5. Okay, so that tells me that it starts, the radius is 5. By relating the volume, the surface area, and the radius of the weather balloon, show that blah 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 blah. Okay. So let's start off by writing the volume formula for the balloon, which will be 4/3 pi r cubed. Let's also work out the surface area, which will be 4 pi r squared. And let's also use this yellow line and say the balloon is decreasing, the volume of the balloon is decreasing. Okay, so what that means is that dv by dt is proportional to, it's decreasing and it's directly proportional to the square of the surface area. So minus the square of the area. So that means that I can write that dv by dt is equal to some constant k multiplied by the area squared. I can also differentiate this, so dv by dr is equal to 4 pi r squared. That could be helpful, and I can also differentiate this with respect to r, and that will be 8 pi r. Okay, so I've got all my things set up, and I need to find dr by dt. Okay, so I want dr by dt, and so I want dr on top and dt on bottom. Well, at the moment, the only one that I've got with a dt is this one. So that one definitely needs to go in dv by dt. And that's good, it's got dt on the bottom. and I want a dr on top, and ideally I want a dv as well, so I can cancel that dv here. So that is exactly what I'm going to do. I'm going to multiply this by dr by dv, and that's going to be perfect. Okay, so dv by dt we said was minus ka squared, and we said dr by dv is the reciprocal of that, so it's 1 over 4 pi r squared. Now a we can substitute in for, so in fact we didn't even need this, apologies, but we do need this, and that is 4 pi r squared times by 1 over 4 pi r squared. Okay, so we've got a 4 pi r squared divided by a 4 pi r squared, so that cancels out at least one of them. So I get minus k 4 pi r squared, and that's it. Okay, great. And we need it to be minus k r squared. Well, that's fine, because I can just call this minus k r squared. Well, I don't particularly like doing that as such. Instead, what I'm going to do is I'm going to say that capital K is equal to little k times by 4 pi. So it's just an arbitrary constant, and so is little k, and so is big K, so I'm absolutely fine to do that constant swap. So I can write minus capital K r squared, and that is what we require. Okay, part B, it just says determine the value. Okay, so we get given an initial condition, and we also have this condition here. So this is the initial one, sorry, this is just a boundary condition. So we've got two conditions, which means I can use that to solve my differential equation. So my differential equation is dr by dt is equal to minus k r squared. So separating the variables, I will get 1 over r squared dr is equal to minus k dt, and need to integrate both sides, and the integral of 1 over r squared, which is the same as r to the minus 2, up the power to minus 1, divide by the new power, so I get a negative, and that's equal to minus kt plus another constant c. Okay, so here's where the initial conditions come in. So my first one is that the radius is 5 at the start. So I will put here minus 1 over 5 by subbing in 5, and that's equal to, when t is 0, so that's equal to c. And then I'll rewrite that now as minus r, or minus 1 over r is equal to minus kt minus 1 over 5, and I'll use my other condition, which is t10 r 4.8. So I'll put in 4.8 minus k times 10 minus 1/5. So rearranging, I get 1/5 minus 1 over 4.8 is equal to minus k times by 10. So I'm going to go to my calculator and I'm going to type in 1/5 minus 1 over 4.8. I'm going to press equals, and then I'm going to divide that by negative 10, and that will give me my value for k. So k is equal to 1 over 1200. Okay, so I've got a full equation now, and I'm just asked to work out t when r is 4. So my full equation is minus 1 over r is equal to minus 1 over 1200 t minus 1 over 5. I will just turn everything positive, just to make it slightly easier. And I will sub in r equals 4. So I will get 1 over 4 is equal to 1 over 1200 t plus 1 over 5. Times through by 1200, so I get 300 is equal to t plus 240. So t is equal to 60. Question 10, it's basically asked me to differentiate cot. Okay, no problem. Let's say that y is equal to cos x over sin x. So using the quotient rule, that's going to give me dy by dx is equal to, remember this one is u, this one is v. So we start with v, multiplied by du by dx, and cos x differentiates to minus sin x. And then there's always a minus in between, and we start with u, and then we multiply it by the derivative of v, which is cos x. And that's all over v squared, which is sine squared. Okay, so the top line reads minus sine squared x minus cos squared x all over sine squared x, and we can take out a factor of minus 1, which will give me sine squared x plus cos squared x all over sine squared x, and of course sine squared plus cos squared is 1, so minus 1 over sine squared is minus cosec squared. Perfect. Okay, and now we are asked to find the second derivative and then sub it in so that we only have it in terms of y. Okay, let me differentiate it. So this is dy by dx. So the second derivative, the 2 comes to the front, bring the power down, keep the thing inside the bracket the same and drop the power down by 1. But then we have to also multiply by the derivative of the bracket. And the derivative of cosec is minus cosec cot. So that's in your formula book. So we're going to end up here with 2 cosec squared x cot x. Okay, so let me differentiate it. So this is dy by dx. So the second derivative, the 2 comes to the front, bring the power down, keep the thing inside the bracket the same and drop the power down by 1. But then we have to also multiply by the derivative of the bracket. And the derivative of cosec is minus cosec cot. So that's in your formula book. So we're going to end up here with 2 cosec squared x cot x. Okay, so now we're going to have to use the identity. We knew that from the start y was equal to cot x. So y squared is equal to cot x squared. And our identity for cot is 1 plus cot squared x is equal to cosec squared x. So therefore cosec squared is equal to 1 plus y squared. So we get two lots of 1 plus y squared, and cot is just y. And I think they wanted it written as 2y 1 plus y squared, like that, if I'm not mistaken. Yeah, perfect. Okay, question 11. I can see here that I want to convert it to rcos. So if I want to convert it to rcos, then the coefficient of the cos is my value for a. So in this case, a equals 1. And therefore, the coefficient of the sine is my value for b. So b equals root 3. Okay, so all I need to do then is write that r is equal to the square root of a squared plus b squared, which is equal to the square root of root 3 squared plus 1 squared, which is equal to the square root of 4, which is equal to 2. And alpha is always equal to tan to the minus 1 of b over a. So in this case, that is tan to the minus 1 of root 3 over 1, which is tan to the minus 1 of root 3, which is it in degrees? It's in degrees, so that's 60. So therefore I can write that f of x is equal to 2 cos x minus 60. State the maximum value of f of x and find the smallest positive value of x for which this maximum occurs. Okay, so the maximum will occur when the cos function is at the maximum, which is 1. And when that is the case, I get f of x is equal to 2. Now, when does this happen? Well, if I take cos to the minus 1 of 1, I get 0 and 2 pi, or should I say 0 and 360. So therefore x is equal to 60 and 420. But we are told, it says the smallest positive value of x for which it occurs. So I can reject this one and accept this one. Okay, great, that was part B. Now on to part C. It says the temperature of the water in a tropical fish tank is modelled by the equation, blah, 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 blah. And it says that T is the time measured since midnight. That's quite useful. State the maximum temperature of the water in the tank and the time when this maximum occurs. This is a very similar question to the one we've just done. So let's first off write T as 32 plus 2 lots of cos, and this time we're not looking at x like we were before, we're looking at 15t. So we have to write 2 cos 15t and then minus 60. And again, we're asked to maximize this. So max t will be when the cos function equals 1. So it'll be 32 plus 2, which is equal to 34. And this will happen when the cos function equals 1. So therefore 15t minus 60 will equal 0 or 360. So therefore 15t will equal 60 or 420. So t will equal 4, and divided by 15 is 28. Okay. it says that T is between 0 and 24, so we need to reject that one and just accept that T is equal to 4 at the maximum temperature. Okay, part D, it says show that the temperature of the water in the tank reaches 30.5 at this time and at this time. You may not verify the answers in this part. Okay, so you have to work it out rather than just subbing it in and showing that it is the case. So we want the temperature to be 30.5, and that's equal to 32 plus 2 cosine 15t minus 60. So we will subtract 32, which will give me minus 1.5, and we'll divide that by 2 as well, and that will equal cos of 15t minus 60. So we'll go to our calculator and we will change to degree mode, and we will do cos to the minus 1 of minus 1.5 over 2. Okay, and we will get 138.5. So 15t minus 60 is equal to 138.5. And then we always find the second value straight away. That should be 0.6 actually, sorry. The second value will be 360 minus for cos. So 221.4. Okay, and then we add 60 and then divide by 15. So that's 18.76. That'll be a value for t. And we'll do the same for 138.6. We will add 60 and then we will divide by 15. And that gives us 13.24. Okay, so as actual times, this is 13 hours and 24, I guess 24% of 60 minutes, which is 14.4, so 14 minutes. And the other time is 18 hours and 76% of 60 minutes, which gives me the minutes as 46. And I believe that's what they asked for. And we are done. Fantastic. Like, subscribe, share, and have a good day. Bye for now.